Hello everybody and welcome. Today we're going to be covering some trigonomic problems. Let's dive right in. Let's get started. All right. So what's this first question? The tangent function is equal to the ratio of an angle's opposite side to an angle's adjacent side in what type of triangle? All right. So this is talking about the SOHCAHTOA. And when do we use SOHCAHTOA? It's specifically talking about the tangent portion. Well, we use these trigonomic identities for right triangles, looking for these other angle measures or looking for these side lengths. So this is going to be a right triangle. Awesome. Which equation cannot be used to find the value of y? Alright, so here's y. What would it be? Well, let's look at 9.66. We could have, to look for y is the hypotenuse. Again, let's write down SOHCAHTOA. Y has to do with our hypotenuse, so we can use the sine of 9.66 or the cosine of 9.66. So answer choice A checks out, and answer choice, and what's our other angle? Our angle here must be 80.34. And again, y is our hypotenuse, so we can use sine or cosine because it has to deal with the hypotenuse. Tangent has nothing to do with the hypotenuse of our triangle. It has to do with the opposite and adjacent sides. So it cannot be tangent of 9.66. So this must be our answer. Awesome. Let's change colors. Let's go to a nice green. Sine squared plus cosine squared of 30 equals what? Okay, well this is a trigonomic identity, and this falls straight from Pythagorean's theorem. Sine squared x plus cosine squared x equals 1. And it doesn't matter what x is. X can be anything, any degree of whatever. No matter what, it's going to be 1. And this falls, you can kind of see it by studying your unit circle. Remember, the unit circle is unit 1, so this point out here is, oops, let me get my pen. This point out here is 1, 0. This point up here is 0, 1. And whenever we square our sine and cosines, we're going to get the value of 1. And you could also solve this by using Pythagorean's theorem on a right triangle. If you would like to see that proof, let me know it in the comments down below, and I'll definitely get it to you. But this answer must be 1. All right. Which expression is equivalent to sine pi over 3? Well, okay, let's think about this. Let's draw our unit circle. What is pi over 3? Well, whenever solving trigonometric problems, you often have to convert between radians and degrees, kind of just depending on whatever the problem's asking for. And the way to convert between the two is radians times 180 divided by pi equals degrees. So if we do pi over 3 times 180 over pi, Then our pi's will cancel. And 180 over 3 equals 60. So this is 60 degrees, whichever way is most comfortable for you to think about it. So 60 degrees is around this point. And what do we know? You kind of need to have your unit circle memorized. If you don't, just pull one up, look in your textbook, pull it up online. I don't necessarily think you have to have it memorized, but I just happen to have it memorized. Okay, so this is 1/2 and then root 3 over 2. So our sine value is the root 3 over 2. It's always cosine, comma sine. And so when will we also have another root 3 over 2? Well, sine is in what value? It's the y value, right? We have our coordinates. Our coordinates are x comma y. Our coordinate is cosine comma sine. So when do we have another y coordinate that shares this position? Right here. Whatever this value is, it's also going to be sine of this value is also going to be root 3 over 2. I'm looking at my answer choices, and I see a 5 pi over 3, and I see a 4 pi over 3. This, what we are looking at right now, is just simply pi over 3. And this value, it looks like would be, well, what would this value be in degrees? It would be 90 plus 30. This would be 120 degrees, which would be, it wouldn't be either of these. So what about cosine? Well, when is our cosine value equal to root 3 over 2? Our cosine value is equal to root 3 over 2 whenever our angle measure is 30 degrees. When our angle measure is 30 degrees, or at pi over 6. Pi over 6 and 30 degrees are the same thing. So cosine of pi over 6 must be our answer. And again, this problem has to do with understanding your unit circle and being able to maneuver around it. I hope I explained it well in this problem. Again, we first looked at here. This would be an answer if it was in our answer choice, but it was not. This value would be 2 pi over 3, right? And we just don't have that here as an answer choice. So then we go on, we think about our cosine values, and we know our cosine values, and we look at our unit circle and we see that it would map at 30 degrees, which was an option at cosine pi over 6. All right, let's finish up. Let's do our last problem for this video. What do we have? What is the value of cosine of 90 plus sine of 90? Well, even if you don't have your cosine and sine values memorized, I would hope you could figure out this answer from understanding the unit circle. And again, cosine and sine of 90, it's going to be this point right here, because this is the 90 degree point. And what point is this on the unit circle? Well, we've gone nowhere for our x, and we've gone one full unit up for our y, as it's the unit circle. So cosine plus sine of 90 is just going to be 0 plus 1, which is 1. Excellent. All right, guys, this was some trigonometry warm-ups. In next videos, we're going to be doing more trigonomic function problems. They're probably going to be a little bit harder than this, so if these problems seemed easy, just stay in this playlist and you'll see more ahead. Alright, thank you so much for watching. Until next time.